Okay, in the next question, we have a function of two variables, so it has continuous partial derivatives, and we have 4 points, a, b, c, and d, right? And we are given the directional derivative of f at the point a in the direction of the vector ab, again at the same point in the direction of the vector ac, and we need to find the directional derivative of f at the same point f in the direction of the third vector ad, right? So let me so it is a good idea to kind of make a plot of what's going on, and here is this plot, right? So here are all the points a, b, c, and d. So the direction from a to b, notice that the direction from, so we are given the directional derivative from a to b. So from a to b is 3. I don't know, let me write it 3 here. And the directional derivative in the direction from a to c is 26. And we need to find the directional derivative at the point a in the direction from a to d. Well, but once you plot it, it kind of becomes, I mean, it looks strange and scary at first, but once you plot it, you realize that the direction from a to b is just horizontal. And the directional derivative in that direction is just the partial derivative with respect to x. And the directional derivative in the vertical direction, so AC is just, is pointed in the direction of the y-axis, which means that the directional derivative along AC is just the partial derivative with respect to y. And basically, essentially what we are given are partial derivatives of our functions with respect to x and y. So which means that this is really a familiar type of questions. It's just that it is a little bit disguised, but essentially, well, maybe if you don't know how to plot it, or let me just explain how you can do it, right? So the AB in the direction of the vector AB, so AB is 3 3 minus 1 3, which is 2 0, right? And it means that AB is just parallel to the x-axis, and by definition, the directional derivative in the direction parallel to one of the axes is just the partial derivative, right? So what it tells us is that this number 3 is just partial derivative of f with respect to x at the point a. Well, okay, so then AC is going to be 1 7 minus 1 3. So this is 0. 7 minus 3 is 4, I guess. And this is parallel to the y-axis and points in the same direction. So which means that f. So the directional derivative in that direction is just the partial derivative with respect to y. So fy at the point A is 26. Okay. The next stage is to find the vector u, the unit vector in the direction of AD, right? So let's find the AD first. So AD is really D minus A. So let me just try the answers. 5, 15 minus 3 is 12. Right? So the vector u, the unit vector in that direction, is going to be AD divided by its norm. So this is 5, 12 divided by square root of 25 plus 12 squared is 144. This is 13, so this is 5 over 13 and 12 over 13. So the answer is going to be just the dot product of u and our gradient vector. So the answer is going to be 3 times 5 over 13 plus 26 times 12 over 13, which is 327 over 13.